Hello, everybody. Thanks for joining today's session about smart card authenticated file services. This topic is actually quite exciting, and I'm happy to announce and discuss this topic with you. It's part of our endpoint announcement, which was launched yesterday, and we as Citera, we always strive to improve and constantly, continuously introduce more and more security enhancements and features that will improve your data security and governance. So, as I said, I'm very excited to kick things off. But let's start with establishing some ground, some common language, so we can start with the easy stuff, the basics. So to give a smooth intro for today's topic, let's discuss about some forms of authentication or user logon or things that we know from our personal lives. So let's take a simple case or a scenario like driving to work every day. Okay, so there's my car, nothing too extravagant, very small, very good for parking. It's not consuming a lot of fuel. And every day when I drive to Citera offices, I take my key with me with the remote, and I use the remote to open up the door. I need to fix my remote, but I'm personally using the key itself. Now, after opening the door, I need to type in my code because my car is connected to the immobilizer. I need to input the code, otherwise I won't be able to start the engine. After I enter my code, now I can put on the key in the ignition and turn on the car and start driving to work. So this is a very short and simple and I guess a very trivial example of things that we may overlook as humans. We apply certain schemes of security into our personal lives. Things like even going home and opening the door. Everybody probably has a key to enter his house back at home. You always lock it when you go to work or other places. So this is a very small example. If we take another one that is also quite common and trivial action that we do as humans, whenever we want to buy concert tickets and we need some money and we go to an ATM to pull up some money. So first of all, we approach the ATM. We are very security conscious in that area. So always check your surroundings and see that nobody's looking over your shoulder, trying to see the PIN code you need to enter. Now, first thing we do is we enter our credit card onto the ATM machine. Right after that, we go through some basic screens and instructions, and we are asked to input our personal PIN code that we were handed out upon issuing the credit card. Now, after you input the right code, of course you have a predefined amount of tries you can input the code. Assuming you enter the right one, you get the money from the ATM and you can go ahead and buy your concert tickets. Now, another form of authentication or security that we have and we experience also on a daily basis is our phones. So recently, a few years ago, systems like Apple, iOS, Android, they introduced the Touch ID that allows us to basically associate our device with our fingerprints, and you can use just our fingers just to access our phones, either doing that or of course entering a 4 to 6 digit number. So all of the things that we saw up until now are examples of security measures that we take on our day-to-day basis, things that we overlook or not, we don't even focus about them, and we take them for granted. And up until now, we've seen a combination of different types of measures that we can use to authenticate to different types of systems, the phone, the ATM, and even my car. And if we were to establish some common language, or let's call it the human authentication principles, we saw, first of all, let's categorize it as something that you know, something like a password or that PIN code that you need to enter in order to pull out money from the ATM. So here's an example of a password. It's very, very complicated. I hardly believe that this is your password. It's probably more something like this one. And of course, we all have policies that require us to change our password every 90 days. So our next password is likely to look like the following. Not too complicated. There is even actually a study that shows that um, having to reset or rotate our password frequently, it actually makes us choose weaker passwords as users because of the overhead that we need to always constantly update, and we don't want to forget them, of course. So that's why we choose things that are from our personal lives usually, like our names, our son, daughter names, birth date, and some other unique dates that are associated with us. Another form is called something that we have, like that credit card that we used in order to pull out money from the ATM. So this is a physical entity, okay, things that we need to carry on with ourselves whenever we go and whenever we want to perform that specific action. So we got to have the card in order to pull out the money from the ATM. Otherwise, the PIN code will not suffice. And we also saw the iPhone example that's called something that we are. Things like our fingerprint that uniquely identifies us as a person, as a human being, our handprint, or if we take it even more to the extreme, things like our retinal scan of scanning our eyes to ensure that we are who we in fact say and say who we are. Now, what we can see here is that we can see different. I basically categorized all of the measures that we saw in the previous instances onto these three groups. Um, Now, each one of them represents a factor of authentication. So individually, of course, so something you know is a single factor of authentication, something you have as well, and something you are. Now, we can combine each and every one of those authentication schemes or measures to protect um, uh, to protect our identity, to identify ourselves to the system, and then we can start introducing things like two-factor authentication or multi-factor authentication, 3, 4, 5 different measures. Now, the importance here is that it's more there's an advantage of combining measures from different groups, meaning having two passwords to the same system is not that of a very good idea in order to access a service. Okay, you would want to mix and combine them together, and the greatest security measure would be to have them all. Okay, a system or a service that you need to both remember either a password, a PIN code. You got to own something, possess a card um, or some ID that you need to carry on with you wherever you go. And of course, your fingerprint, something that identifies you uniquely. Now, we can take these human authentication principles and we can apply them onto data and data security in specific. So data security and its principles are not that far away from what you can see here. We can apply the same factors, we can mix and combine them with each other and apply that onto our data security. So whenever let's take the ATM example. So instead of accessing, pulling out money from the ATM, let's think of us grabbing a file from a certain service, and so on. So we can apply these schemes onto data security as well. Going forward, we also want to examine the following piece. It's called a server certificate. So each one of the examples I shared with you previously are things that can prove our identity. But as things that we may overlook in our day-to-day job and from the systems or accounts that we log on to and use is that there are actually even a step before that of us basically ensuring that we are speaking to the right entity, the right service, meaning that if we look at this example, for instance, if we look at the left side, we can see that green indication at the top. Before we even arrive to a stage where we as a user need to put our identification, things like a password, we would want to know for sure that we are talking to PayPal and not some rogue or some attacker who impersonated PayPal, right? So there are a lot of instances or occasions where hackers and attackers basically impersonate other services. They even take advantage of situations where they use a um, uh, different words or letters and they utilize us mistaking and inputting a URL or a domain, for example. Let's say if PayPal was spelled with an I, for instance, if somebody foreign from foreign countries used an I. So they all try to get smart and impersonate those services, because what they eventually want to achieve from that is to obtain our passwords. Because if they will show us the same page, if we could see that on the example on the right with the red at the top, we can arrive a page that is completely identical to the one on the left, and we can just go ahead and input our password. What we wouldn't know is that it's basically somebody else out there. He can grab our password, and then later on he can go into my account and then just transfer money or steal my money or other personal effects. So this part is called server certificate. Server certificate is a technology or a way for us to identify that we are in fact speaking to the right with the right service. Okay, it is in fact PayPal and so on. Because what we wouldn't like to happen is, again, for users to access unauthorized or compromised services. So we definitely need to look for ways to improve our data confidentiality. Now, one other primary reason for server certificates is that we would want all communication of us with PayPal to be fully encrypted, because we would want also anybody in the middle to eavesdrop and, for instance, steal our password to the service. So in order to address all of these challenges, first of all, applying those human authentication principles and also improving our data confidentiality, let's examine a potential solution that will allow us to do actually both. And that's called a client certificate. So a client certificate is somewhat resembles a server certificate. We can use this measure in order to ensure the other way, basically, is that not only us verifying that we are in fact talking to PayPal, but also for PayPal to know that they are communicating with a client, with a browser that is allowed to communicate with their system. So in cryptography, basically, a client certificate is a type of eventually a digital certificate that we can use as clients to make authenticated um, communication with a remote service. Now, this certificate can come in various forms. It can be either a soft certificate, meaning it's a software that is installed on a specific device, let's say a PC or a Mac, for instance, or it can also come in a physical form, either via a portable storage device like a USB thumb drive with a digital certificate within it, or of course a smart card. Now, in this aspect, client certificates play a key role in what we call as mutual authentication design, as for both parties to ensure they are communicating with each other in a secure manner, and basically providing each other with assurances, strong assurances of each other's cryptographic identity. Now, in order to leverage this sort of security measure, you would need to employ what's called a PKI, a public key infrastructure. A public key infrastructure is a service that can help you store, manage, and create keys and certificates. And those keys and certificates can be then later on installed on a PC or burned onto a smart card device or into that portable storage device. Of course, there's some trade-offs and advantages and disadvantages of using a physical versus a software certificate. Soft certificates are, for instance, considered as less secure because they are persistently installed on a specific device, and then they may be subject to be stolen at some point. They are stored in specific places on the PC that can be compromised at a certain stage. So definitely using, for instance, a smart card or an actual physical device that you need to possess and you need to have with you at all times improves the security, because at the moment you pull out your smart card from your device, it immediately removes or revokes all of the certificates that were available at that time for that PC that used them. Now, smart cards are actually very common in many. There are many instances or organizations employing and using smart cards today for various types of purposes. We can see financial services that need to ensure, for instance, that all access to data, corporate data, is done through sanctioned PCs, devices. So you wouldn't want any guy coming into the bank with a laptop connected to the Wi-Fi to be able to access the services and systems of the bank. You would want to leverage a technology that will allow you to ensure that all access is done through specific authorized devices or to authorized personnel. Now, the other great advantage here with client certificates is that they can be associated with specific users. They can be very, very personal. I mean, it can be completely personal. So I can have my own certificate, and every employee within the company can have its own digital identity. Okay. So as I mentioned previously, client certificates enable us to address a concept called mutual authentication, is for a client to identify the server and also for a server to identify the client, even before they they challenge each other for information such as passwords and credit cards. Okay, so this is a layer of security that can come um, um, immediately up front. So before we start to exchange sensitive information, before I start to type in my PIN code, before I share my password with PayPal. So what we can see here on the left diagram is a basic communication flow of what's called a TLS handshake. This diagram is handed out to any computer science student today. And it shows the basic communication flow of a client to identify a server and trust it. Um, and we can see this communication flow, but again, as it says on the top, the server doesn't know anything about the client. So the client can be some compromised PC, something that was attacked by a hacker. So a user has downloaded a file that completely compromised his PC, and now a hacker has access to perform actions on the user's behalf. Now we can actually do better than that. Okay, the TLS protocol, the handshake can basically be extended and allow a two-way identification. So not only for the client to know the server, but also the server assures that it's communicating with the appropriate sanctioned client. So we can see those additions to the handshake. So these are pretty trivial. So as part of the server identifying the client, it will ask for the client certificate. So the server will ask for it. The client will present its either soft or physical certificate derived from a smart card or that USB thumb drive. And that verification checking will occur on the server side to ensure that the integrity of the certificate that was shared by the client. Okay. Now at this point, let's have a look on how this scheme of mutual authentication is applied with CTERA. So as part of our endpoints announcement, we are going to announce the availability of our uh, authentication of mutual authentication that is based on either soft certificates or even smart cards. So in this diagram is actually put out very, very simply. We have our CTERA portal, that's our web interface, or it's our management platform that all of the CTERA devices connect to, that is installed completely privately in your cloud. And CTERA portal is loaded with a server security certificate. Now this certificate will allow clients to ensure the CTERA portal's identity, and that certificate can also be signed by a public or a private certification authority, a CA basically. Now a public certification authority is companies like VeriSign, GoDaddy, so on and so forth. But for companies that employ a PKI infrastructure, a public key infrastructure, they can also issue. They also are they are a certification authority for themselves. This means that they can act as their internal GoDaddy and VeriSign equivalents. And by doing that, they can issue certificates that will be eventually loaded to any of the services or the servers and the workstations within that company. So the private certification authority from the public key infrastructure issues a certificate that is loaded to CTERA portal and also issues a personal certificate for John Smith. And we have John's PC on the left, and we can see at the bottom he has a client certificate that is issued specifically for him by the same certification authority that issued the certificate for the CTR portal. Now, upon opening, let's say for instance, let's take the browser for example. Upon opening the browser and attempting to browse to CTR portal's web interface and upload a file, for instance, or download a file. So before doing that, both parties will identify each other. Both CTR portal and John will first check that they ensure the identity of each other and then prompt for other factors of authentication. So we can open up our Chrome. We can just type in ctera.acme.com. Let's assume that's the domain that CTR portal was set up with. And by arriving to the web page, it automatically triggers the handshake that we saw in the previous slide that will verify both the client and the server's identity. Now, at any error at this process, the connection will be, of course, terminated. So you will end up in a white screen saying that some error occurred and you're unable to access the system. And since the unique thing here is that since the certificates are also issued to specifically for specific personnel within the company, we can also uniquely identify the incoming user. So we know that is John. We know that it's Sarah logging in from her desktop. Now we can even do better than that. Let's say we have scenarios where people leave the company or certain access to specific systems needs to get revoked, or we have again someone that left the company and we have an evil employee attack, and we want to quickly and centrally revoke all access to all enterprise services, not only Cetera, but other services that you have that already leverage a public key infrastructure. So for that, we also added support for what's called OCSP, the OCSP protocol. OCSP is initials for Online Certificate Status Protocol. It's a regular client-server communication that allows applications like Cetera to verify that certificates are not revoked. So upon receiving John's certificate, when John will present it to Cetera portal, we will take it and then consult with the OCSP server to get a go, no-go answer to know whether or not we should authorize that user into our system. Now, the OCSP server can check things like expired certificates, revoked certificates, and so on and so forth. Sorry. Okay. So let's zoom in into Cetera portal and let's have a look at how the configuration looks like. So it's quite simple. It's as simple as selecting this form of authentication through a drop-down list. So as you can see, this single sign-on configuration page that you can access as a global administrator of Cetera portal. So you can restrict all data access, all data access to Cetera portal to be done through client certificates. And you can also specifically tell Cetera portal whether or not you want to perform revocation checking for those incoming client certificates. So it's quite simple. It's again as simple as choosing an item from a drop-down list. This will automatically turn on this security fence and will be immediately enforced by Cetera portal. Now let's examine the use cases that we can derive and address throughout this integration of client certificate or mutual authentication to our software stack. So first of all, as mentioned previously, we can enable access only to authorized personnel or through authorized devices. So if we potentially look at use cases for that, if we want to know that it's specifically John or those specific users accessing the system, or we want to choose a different direction of we want to be able to launch the data service accessible only through specific hardware devices, so workstations. So I can set up software or of course use smart cards for physical workstations, and this way restrict access to CTR portal only for those authorized devices. Now, as part of our integration, we support all types of users that we have in our system. So the breadth of support is from end users to administrators and also what we call staff administrators and so on. And what this also enables us with is a great improvement to perform collaboration in a secure manner. So if we examine the most trivial way of sharing files today from other systems that we know from our personal lives, we can just simply right-click a file and we can choose to generate a link to that file and just fire it away through email. Now, this is not very secure, right? Because we have then we have no way of associating that link to a specific individual. So by using client certificates or smart cards for that matter, we always know the user's identity. So when the recipient will attempt to click that link, it will have to automatically go through this handshake process, two-way handshake process, and this will allow the server to identify the client, and by doing that, the server can also offer better tracking and auditing for all of the actions that were performed by that specific user. So by integrating smart card support to CTERA portal, now we know the identity of the incoming users whenever data is shared through public interfaces. Of course, there are built-in mechanisms for performing even more secure sharing and collaboration within our platform, but we even get a great improvement in the most trivial and very easy to use ways of simply sending out a link. And full auditing, extensive login for any actions performed by that user. So we can read off that client certificate and know that it's John Smith, and then log any action in the system for access, downloads, renames, previewing data, so on and so forth. Now, if we also examine the user experience derived from the client certificate integration, is actually quite an improvement as well. So we initially started the webinar with establishing the human security principles, and we saw different groups, and we also discussed about the option of combining some of them. So by choosing each and every one of them individually, it's called a single factor or one factor of authentication. By combining one factor authentication with smart cards, for instance, so this means that the smart card is something that we own, is the only measure that we use to authenticate to a system, we can enable single sign-on to CTERA portal upon attaching the smart card to your PC. So by attaching it, just browsing to the address, you will find yourself automatically logged into our system, ready to go with uploading, downloading files. Now, we can apply even greater security than that, since the smart card, using the smart card providers that are given natively to us by the operating systems of Microsoft and OS X. And we can also protect those client certificates with a passcode. So basically, by attempting to authenticate using a smart card, you will also be challenged to input that PIN code. That is something that you know, to improve security. So and then this way, of course, establish uh, um, a connection to the portal, and then you'll get access to your files and folders. So here we can see an example of how it looks on a Windows system. Of course, Mac has its own equivalent for this PIN code page. Okay. To summarize and discuss about the applicability um, and where smart cards and client certificates are used today. So they are used in highly secure environments. It varies from defense to government agencies, civilian agencies, and also commercial. We can see a lot of instances of banking, attempting to protect the banking services, ensuring access is only authorized to specific personnel and devices. We can also see those smart card readers in a lot of government agencies where they need to use a reader with their own dedicated um, uh, um, certificate that they need to use in order to log on to the systems. Utilities, electricity, transportation, treasury. Um, there are a lot of highly secure, highly sensitive data today, and this data is secured using measures such as client certificates. Um, and after, and in most cases, of course, it's not only done using a single factor. In those specific sectors, you would most likely to find two-factor and even multi-factor authentication, combining those principles that we established earlier. Healthcare, also a lot of sensitive and very delicate information about patients, about researchers that requires the military grade of security. And all of that is natively supported and combined with CTERA Portal and the services that we offer. So stay tuned for um, our announcements for endpoints that was launched yesterday, and I encourage you, of course, to learn more and engage with us and discuss with CTERA about how you could also potentially leverage smart cards and achieve both the benefits of um, greater security, data security, and also user experience for your enterprise. Um, of course, this is only a tip of the iceberg in terms of the security features that we have as part of our 5.5 release and the endpoints announcement. We continuously, as I mentioned previously, improve and add more and more controls and auditing for any action and, and strive to provide you with the tools that you can always govern and secure your highly sensitive data. Thank you, everyone.
Simon, we have a question. The question is, will CTERA be offering smart card readers and cards as part of the solution?
Mm-hmm. So at the moment, as part of the solution, this was not planned. Um, we are using them for internal purpose at this stage. This is something that is under exploration at this point, but is not planned for the initial release.
Okay. Other questions? No? Okay. Oh, there's one other question. Will CTERA be offering a certificate making program or just use a third party?
So as part of our support, we will be offering uh, the ability to start a process of issuing certificates through our platform, but the public key infrastructure, our recommendation is to leverage other systems for that purpose.
Okay. Thanks so much, Simon. So, so thanks everybody for joining today. Lauren, could you just make me the presenter real quick, or Simon?
Sure. There are 3 people called CTR Networks. I hope I picked up the right person.
I
Yeah.
got it.
Okay.
Hey, you did. Thank you. Thanks, Simon. So just wanted to, excuse me, just wanted to draw everybody's attention to additional webinars that we host to help you learn more about our products and the use cases. Today we conducted the Smart Card Authentication File Services webinar. This will be made available on demand for everyone to go back and review or catch anything that you missed. And we make all of our webinars on demand to give you the ability to learn more about CTAR whenever you'd like. On June 30th, we're doing a more extended session to cover all of the endpoint announcements that we made this week. Simon and I will be conducting this session, and if you want to learn more about what we announced, then please go to cterra.com. Look at the bottom of the homepage, and we always host our newest announcements here. So, so there's a lot of new features and capabilities that we've announced as part of this this new release. Over 50 new features and functionality was announced yesterday, and we encourage you all to read more about it, both in the press release as well as in the blog post that we wrote about the solution, and then finally in the webinar that we'll be hosting on the 30th. So again, thanks everybody for your time.